Hi everyone, welcome back to another Algebra 1 tutorial. In this video, we'll be going over more linear forms and conclusion of linear functions. So the key concepts for this chapter is going to be solving intercepts and slopes, slope-intercept form, point-slope form, parallel and perpendicular lines, and transforming linear functions.
So, using intercepts and slope. So as told in the last video, two intercepts are enough to graph a line, similar to the way 2 points are enough to graph a line. However, we can use the slope and either one of the intercepts to graph a line. For example, suppose we are given a line with slope 1 and y-intercept -2. So first we would graph the intercept, and since we know if a line has y-intercept -2, it's going to be somewhere on the y-axis, or a y-intercept in general. So -1, -2, since the intercept is -2, it would be 0, -2 as the coordinates, so 0, -2. Next, we know that there's a slope of 1. So the only possible outcome for it to be a slope of 1 is that the change in y has to be equal to the change in x. So from this we can conclude that the slope of this line would be something like 1 over 1, or suppose we took a higher number, it could be 6 over 6, or so on, as long as the change in y is congruent to the change in x. So 1 over 1 is what we will take as the slope, which basically means that every time you increase vertically once, you also increase horizontally once. So we could graph a few more points over here as well, and then we could plot them. So -1 would be 1, -2 would be 0, and so on. So if we connected these dots, since we have multiple different dots that we can connect to form a line, if we connect all these dots and get a line, so this would somewhat be like a line. So as you can see, it has a positive slope going from left to right upwards. So slope-intercept form. Slope-intercept form, or y is equal to mx plus b, which you might have heard before. So in slope-intercept form, m resembles the slope, b resembles the y-intercept, and y and x represent x and y coordinates. So for example, y is equal to 4x plus 3. Over here, the slope is 4 and the y-intercept is 3. Similarly, in y is equal to -2x plus 5. Over here, -2 is the slope and 5 is the y-intercept. So using slope-intercept form. So suppose we're given a specific range of values and we're told to write them in slope-intercept form, or a few coordinates and slope. So we're supposed to write it in the form y is equal to mx plus b. So we would use the slope and the y-intercept which is given and substitute them in. For example, we have the slope as 1 over 2 and the y-intercept is 3. Simply we would do y is equal to 1 by 2x plus 3. However, if we're not given either y-intercept or we're not given the slope, and we're given a combination like the slope and the x-intercept, or the y-intercept or any set of coordinates on that line and the x-intercept, and we're told to find either the slope or the y-intercept. So to solve this, let's look at a problem. So suppose we have a line with y-intercept 3 and x-intercept 6. So we could first graph this one out. Then we could plot the 2 points. So y-intercept 3, 1, 2, 3. It would be somewhere over here. And x-intercept 6 would be somewhere over 2, 3, 4, 5, 6. X-intercept 6 would be somewhere over here. So now we can either write down the line like so, or we can use the slope formula to find the slope. So we know that the y-intercept 3 would be 0, 3 as the coordinates, and similarly x-intercept 6 would be 6, 0. Now all we need to do is do 0 minus 3 over 6 minus 0. So 0 minus 3 over 6 minus 0, for which we would get negative 3 over 6. And when simplified, the slope would be negative 1 by 2. So now that we have this slope, negative 1 by 2, and we already have the y-intercept, I need to substitute the values in to get y is equal to negative 1 by 2x, and y-intercept 3, negative 1 by 2x plus 3. So now let's do a few practice problems. So rewrite in slope-intercept form. We have slope 4, so slope as 4, and 0.25. So here, to find the y-intercept, we could first graph it. So just lines to know where each point is. So we have 2, 5, so 1, 2, 1, 2, 3, 4, 5, and we have slope 4. So since we know that it's a positive slope, it cannot go to its y-intercept if it goes forward. So instead, we could go backwards. So 4 over 1 is the same as negative 4 over negative 1. So that basically means we can go 1, 2, 3, 4, and then 1. And then we can go down 4 again. So 1, 2, 3, 4, and 1. And this is where our y-intercept would be. So that would be 0, negative 1, 2, 3. So the y-intercept would be 0, negative 3. And now that we have that, we can just do y is equal to 4x minus 3. And that would be our function rewritten in slope-intercept form. So suppose we have another problem. We have to write it in slope-intercept form where one of the points is on 5, 2, and the x-intercept is 6, 0. So for this one, we could graph it. First, as a first step, we could graph it. So let me jump to the graph. So x-intercept 6, 0, 1, 2, 3, 4, 5, 6. And point on 5, 2. 1, 2, 3, 4, 5. 1, 2. So for this one, the best way to find the slope would be to use the slope formula. So 0 minus 2 over 6 minus 5, which gives us negative 2 over 1, which is the slope. So negative 2 is going to be our slope. So now we have the slope. So one way we could do it is use this slope and draw a graph from 5, 2. So since we know it's a negative slope, it goes down over time. So maybe we should make this higher. So increase the length of our y-axis. Alright, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now that we have extended it, we can just do 5, 2. So 5, 2, so we could just go back 1. So negative 2, 1 is the same as 2, negative 1. So you go back 2 and you go 2 up. So back 2, 1, 2. Back 2, 1, 2. Back 1, up 2. So it goes here. And then finally back 1, up 2. And back 1, up 2. So it looks like it extends further than our anticipated graph. So if we could take this point, which is 3, 1, 2, 3, 4, 5, 6. So we have 3, 6. So 5, 4, 3. And then we could do 6 plus 2 plus 2. Since we know that, or 6. So 1, 2, so 6 plus 2 plus 2 go up here once, twice, and thrice. So 6 plus 2 and a 3, which is 6, so 12. So our y-intercept would be 0, 12. And one way you could check is if you add 0 plus 5, so or you could think of it as y is equal to 2x. So basically, not y is equal to 2x. You could think of it as every time you add 5 to this, you add 10 to this. So which basically means that every time you add 1 to this one, you add 2 to this one, or here. If you subtract 5 minus 1, you're adding 2 to 2. So you're making 4, 4. Similarly, 3, 6. And then 2, 8. 1, 10. And finally 0, 12. Which gives us our y-intercept. So now we can write in slope-intercept form now that we have both the slope and the y-intercept. So y is equal to negative 2x plus 12, which would be our final slope-intercept form function. So now let's look at point-slope form. Point-slope form can be used whenever you have the slope at any point on the line, and is written in the form y minus y1 is equal to m into x minus x1. So x1 and y1 are any points on the line. So if you simplify slope and intercept form after you substitute the values, you can get y is equal to mx plus b. Or at least you can find out what the intercept is. So write in slope intercept form and point slope form, we have 1 by 2, 1 as our point and 2 as our slope. So y minus y1, which is 1, is equal to 2 times x minus x1, which is 1 by 2. And this will be a slope-intercept form. And just to demonstrate, I'm going to simplify this. So y minus 1 is equal to 2 into x, which is 2x, minus 1 by 2 into 2, which is negative 1. Then all we need to do is add to both sides, so we get y is equal to 2x. So for this problem, the y-intercept would be 0, 0. And the reason we know that is since it doesn't display over here. So graphing the line in point slope form. So one way to do it is we can do y minus 1 is equal to 3 into x minus 1, which is our slope-intercept form function. So we could do y minus 1 is equal to 3x minus 3 after simplification. And then we can get y is equal to 3x. Negative 3 plus 1 would give us negative 2. So we know the slope, and we also know the y-intercept, which is 0, negative 2. So with that knowledge, we can say that we can substitute in values. So if we put 1 here, another point would be 1, 1, 2, so 2 to 3 is 6, minus 2 is 4, so 2, 4, and 3, 7. And finally 4, 10. So when graph, we would have 1, 1, 2, 1, 2, 3, 4. So we'd have a graph with a very steep graph, which goes upward. Okay, so we're given to graph a few point slope forms. So y minus 1 is equal to negative x minus 3. So y minus 1 is equal to negative x plus 3. And y is equal to negative x plus 3 plus 4. So we know that slope is negative 1 and y-intercept is 0, 4. So when graph 0, 4, 1, 2, 3, 4, and go down 1, down 1, down 1, down 1. We have a downward slope. So parallel lines. Parallel lines are two lines in the same plane that have no points in common. In other words, they never intersect or hit each other. So all parallel lines have the same slope. However, two lines with the exact same are not parallel but coinciding, which basically means that they're the same exact line. So suppose we have this line with slope 2 by 3 and their function is y is equal to 2 by 3x plus 5. We need another line which is y is equal to 2 by 3x plus 5. Both of these lines are coinciding. However, suppose we do 7, then these lines become parallel because they have the same slope but different y-intercept. So all vertical lines are parallel, or lines with undefined slope, and all horizontal lines are parallel, or lines with zero slope. So perpendicular lines on the other hand are lines which, when intersect, form a 90-degree angle. And the slope of those two lines which intersect are negative opposite reciprocals, meaning that the line slopes when multiplied with each other. So we have 2 by 3 and negative 3 by 2 as the two lines. If you cancel it out, we get negative 1, because negative 1 by 1 is basically negative 1. So we can say that these two lines are perpendicular. And also, a vertical line and a line with zero slope are always perpendicular, and they always form a right angle. So identify the group of lines. We have y is equal to 6x and y is equal to 6x plus 5. So since these lines have the same slope but different y-intercept, they're parallel lines. Next we have y is equal to 6x, and we have y is equal to negative 1 by 6x. So if you see closely, if we multiply these slopes with each other, so negative 1 by 6 times 6, we actually get negative 1. So we can say that these lines are perpendicular. So if we want to see if two lines are parallel based on their slopes, so we're given negative 2, 5 or perpendicular. So we have two lines. So these are points of line number 1, and these are the points of line number 2. And we need to find out if these lines are parallel. First we do the math, so negative 1 minus 5 over 2 minus 2, which will give us negative 1 minus 5 over 4, which is negative 6 over 4. And we also have 2 minus 5, which is negative 3, 6 minus 4, which is 2. And if we simplify these, we also get negative 3 by 2. And since these two lines have the same exact slope, we can conclude that both of these lines are parallel. So transforming linear functions. So a family of functions are a set of functions who have characteristics in common. The parent function is the most basic function in the family, the most basic parent function being f of x is equal to x. So transformation is the change in position or size of a figure. For example, the function f of x is equal to x plus 1 is up 1 from f of x is equal to x. So if you graph it in line, which is basically y is equal to x plus 1 and y is equal to x, if you graph it like so, so for this one, the base point would be 0, 0, which for this one would be 0, 1. So right off the bat, we can see that these two lines have a difference of y is equal to 1. So as it goes higher, as this one increases gradually, this one also increases. So at the end, we have two different lines which are parallel, but the transformation is 1 up. So the transformation is y plus 1. That's the transformation for this line. So what we just saw there was a translation, and it's a type of transformation that moves the point in the same distance in the same direction. So suppose we have the function fx is equal to mx plus b. The graph, and when the y-intercept b is changed, this is changed vertically. So suppose if b is increased, then it translates up, and if b is decreased, then it translates down. So the next one we'll be going over is rotations. So a rotation is a transformation about a point. So think of it as a turn. So when the slope m is changed in the function f of x is equal to mx plus b, and the graph is rotated about a point 0b, this changes the line's steepness. And basically it only rotates when you change the slope. So it's kind of like you have the following line, and it's rotated along this, so the line looks like this. So when you rotate it along the line, you're changing the slope. So if suppose you put it like this, you're basically changing the slope by rotating it. So suppose this was negative 2, it could now be something else, which would obviously be less steep. So finally, let's look at one last type of translation, which is reflection. So when the slope m is multiplied with negative 1, and f of x is equal to mx plus b, it is reflected across the y-axis, which basically means you have a line like so. And if you change the slope by -1, you're basically flipping it to the other side. So you're basically flipping the line to the other side. So suppose this was a mirror, then you're basically taking this and moving it over here. So now let's do a few problems on describing the transformation. So we have f of x is equal to x and g of x is equal to x minus 4. So when you look at this problem, we can see that the y-intercept is changed. So we can say that this is a translation going down 4. So let's look at one more problem. So we have two lines. We have f of x is equal to 3x plus 4, and we have f of x is equal to -3x plus 3 or 4. So here we see that it's been multiplied by -1. So we can say that this is a reflection. So finally, for the last one, we're given f of x is equal to x plus 1 and g of x is equal to 1 by 2x plus 1. So here we can see that the slope has been multiplied by 1 by 2. So we can conclude that this is a rotation.
So that's all I have for this video. If this video helped you with the rest of linear functions, make sure to like and subscribe. Thanks for watching and bye!